how robust the membrane is, because it's a membrane technology. So the trick is to make the membrane sensitive enough to the ion you're trying to measure, but at the same time it's robust enough in the aeration basin, because in the aeration basin everything goes, right? Bubbles and things. And so I think recently in the industry, a lot of companies have coming up with these things because they found a way to perfect the technology, the membrane, so to speak. So it's very similar to pH measurement. It's like a voltmeter. You have a reference in the ion selective electrode. So this part is the part that's sensitive to whatever you're measuring, either nitrate or ammonium. And it's like a voltmeter, so the differences between the reference and ion and the measuring is it's proportional to your concentration. It's pretty easy, actually. So color and turbidity is not an issue, because it's just looking at the ion directly, concentration. We'll go next. This is kind of a marketing slide. It's comparing the colorimetric technology, which Anderson Hauser has too, and also with the ISC technology. Even though it's not as precise in the low level, but it's repeatable. It gives you nice trends. And you need something in the aeration basin to respond fast enough so you can turn off your blower or turn it on fast enough. And that's pretty much the heart of ISC. And for colorimetric, it's a batch reaction, so you have to wait about 5 to 10 minutes for the next batch to happen. And between 5 and 10 minutes, a lot of things can happen to these bugs. And the measuring range is a lot higher too than the colorimetric measurements. It's less maintenance. And I brought a little thing. You can hit a squirrel with this. Not that, I tried it. So pretty much we have 2 probes in one. Here's the reference. It looks like a pH probe, and the ammonium, which is red, and nitrate. And you might ask, what's this for? Well, nitrate measurement. One big interference for nitrate is chloride. And for ammonium, there are 2 interferences. There's potassium and sodium. So if your process is known to have these interference, you can have a potassium or chloride electrode here to compensate. So that's kind of a backup. And you have, you can't see here, you can see later, but here are little holes. This is a cleaner mechanism. And also you have your temperature and the ground. So this is all in here. And ta-da, I took it out. No, I didn't. This is a different demo. So you can, when you need to maintain or calibrate a probe, you can just take off the head and do it. It's a semi-annual type of maintenance. Okay, I won't go into it too much.
Is the probe temperature compensated, or is that just
Yes.
another measurement?
Yes. Yeah, because temperature affects how fast the activity of the ions, not as pertinent as pH, but it does have a little bit to do with the ion activity. So we're measuring the ion activity and the concentration. Yeah, because how fast they're hitting the membrane does affect a little bit of the voltage difference. So that's what I just went over. And at first I was like, man, this is really, looks like it's going to fall off any time. But it's been there for a while now. It's in Germany. And this technology has been proven in Europe. We're rolling them out here in the US. Again, I think fast responding is really, and ease of maintenance is what we're going for here. And it comes with a little nice calibration kit. Membrane, I think I mentioned twice a year, you change the membrane. Here, just more marketing slide. Wet chemical versus ion selective electrode.
So ion selective electrodes are a new technology that's being introduced in the U.S. to do more continuous measurements of wastewater streams.
Yeah. Ion selective electro, it's been around, I mean, in the lab, we use them a lot. Ion selective to chloride, ion selective to dissolved oxygen, ion selective to nitrate. And in a way, pH is an ion selective electrode. It's selective to hydrogen ions. And wet chemical, again, it's very high precision. If you need nitrate ammonium in the low level, need it very accurate, wet chemistry is the way to go. So it depends on your application. And again, we have them installed 240 loops in Switzerland. That's where it started. And if you do this correctly, you see nice data like this, where they cross. And you can see where ammonium's going up. When it's down, stop the blower. When it comes back up, and when it's come down, stop the blower. And this is a little slide of comparison with the lab, even though it's not dead on with the lab data, but the trend matches. And that's what we're going for here. Again, with ammonium, when it comes up and when it stops and slows down, you see they stop the blower right away. This is the right way to use this instrument. It's hard to see, I'm sorry, but you can come here and look at it later. So these are just some pictures of the installation directly into the basin. You don't need a filter probe or a filter tube to filter out the stuff. Just directly in situ. You can also put in the pipe. And I get a lot of questions, why don't we do control by ORP or dissolved oxygen? I kind of just proved it to you that dissolved oxygen it's not all that precise. And some people say, hey, we do it with ORP. So this is one of the data we grabbed from Switzerland. They say, yeah, we're doing this nicely, with ORP. And then when we put ammonia, I don't know if you can see, ammonia is going up and down here, and then comes back. So by ORP alone, or alkalinity alone, it's tough. It's kind of like, why would you want to use anything other than a ruler to measure distance? Right? It's like I'm trying to use Carlos's feet to tell me how long something is, right? A foot is. It's different. So that's really what I want to kind of just plant the seed in your head.